Hello students of class 9, welcome to my class. Today I will take chapter 8 quadrilateral. Earlier we have taken up to theorem 8.5. Today I will take 8.6. Look at the book, page number 164. Look at your textbook. Theorem 8.6, the diagonal of a parallelogram bisect each other. We have to prove this. So, to prove this, we have to draw a parallelogram. So, let us draw. So, ABCD is a parallelogram. And here you have to prove that diagonals of a parallelogram bisect each other. So, let us draw two diagonals of it. So, when we draw two diagonals, it intersected at a point and we have given the name as O. So, whatever I have drawn, let us write. Let ABCD be a parallelogram. Let ABCD be a parallelogram, AC and BD be the diagonals intersected at O. Okay, and now we have to prove that it is bisected each other. That is, to prove that after intersecting, what happened? Each diagonal is divided into two parts. So, we have to prove that OA is equal to OB and OA is equal to OC and OB is equal to OD. So, construction already covered in this part. Now, directly we have to prove it. To prove, we will consider the parallelogram properties. Properties of parallelogram. Proof. So, since in a parallelogram opposite sides are parallel, equal and parallel, so we will write here, since AB parallel to CD, AB parallel to CD and considering AC as transversal. So, what we are getting? If AB parallel to CD, AC is transversal, then we are getting what? BAC, angle BAC is equal to what? Angle ACB. ACD. BAC is equal to angle ACD. So, here you can make angle BAC as BAO is equal to angle ACD, we can write angle OCD and we will mark it as equation number 1. Then again we will consider the other two sides, or I will consider same side with again earlier we have taken AC as diagonal, now we will take BD as diagonal. Again AB parallel to CD, comma, BD as diagonal. Now we are taking BD as diagonal, BD as transversal. This diagonal we are considering it as transversal. Then what we are getting, you see, ABD, angle ABD, angle ABD is equal to angle BCD, angle BDC. Okay, angle ABD is equal to angle BDC. So if we make short, the angle ABD will become angle ABO is equal to what? Angle BDC will become ODC. Mark it as equation number 2. Now we will consider these two triangles, because we will have to show OA is equal to OC and OB is equal to OD. So these two sides, OA and OB, is the part of angle OAOB, and OC and OD are the parts of COD. Therefore, by in triangle AOB and triangle COD. What we are getting in these two triangles? You see, earlier we have marked equation number 1 and 2. Okay, these two are the parts of these two triangles. So in equation number 1, what we are getting? BAO is equal to angle OCD. BAO, this angle is equal to angle OCD, this angle, and angle ABO is equal to angle what? ODC. These two we will get from where? From 1 and 2. And that is, we are showing these two triangles are congruent. To show any two triangles are congruent, we need 3 parts. Here we already written 2 angles, and you see these including sides are equal, because AB is the part of parallelogram, that is side of a parallelogram, and CD is the opposite side of AB. So, and AB is equal to CD. What is the logic for this? What is the reason for this? This is since opposite sides of parallelogram. Opposite sides of parallelogram. Okay. So we can say that angle side angle, angle side angle. So by therefore by angle side angle, ASA postulate triangle OAB AOB is congruent to triangle COD. So we have already showed that these two triangles are congruent. So now again, so if these two triangles are congruent, then what we get? you know, after showing two triangles are congruent, the remaining parts of these two triangles are equal by CPCT. So here we can write, therefore OA is equal to, OA is the part of triangle AOB, OA is equal to OC, and OB is equal to OD. These are by CPCT, corresponding part of congruent triangles. So if corresponding part of congruent triangles, that is these two sides are equal, so we can say that hence what was your question? The diagonals of a parallelogram bisect each other. Hence the diagonals bisect each other. Proved. So here we proved theorem 8.6. Now we will proceed to theorem 8.7. What is theorem 8.7? In the same page 164. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. We have to prove that in a quadrilateral, if the diagonals are bisect each other, then we have to prove that it is a parallelogram. That is just opposite of the previous theorem 8.6. So prove this. Let us draw a quadrilateral. As we have to prove that it is a parallelogram, so we will draw a parallelogram, because a parallelogram is also a quadrilateral, nothing but a quadrilateral. So we are drawing a quadrilateral, that is a parallelogram. So ABCD is a parallelogram theorem. Six. 8.6. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. That is here mentioned that it is already bisected. That is OA is equal to OC and OB is equal to OD we are getting, and we have to prove that it is a parallelogram. That is, we will use alternate angle property. So let ABCD be a quadrilateral. ABCD be a quadrilateral. The diagonal SC and BD bisected each other. It is mentioned in the question, bisected each other at O. The diagonal is bisected, so let us draw the diagonals SC and BD bisected each other at O. If it is bisected, then therefore we can say OA is equal to OC and OB is equal to OD. Now we have to prove that this quadrilateral is a parallelogram. To prove that, ABCD is a parallelogram. In short, we are writing parallelogram. So to prove it, again we will consider this equation, triangle AOB and triangle COD. You see, and here we will use the property of alternate angles. if the alternate angles are equal taking a transversal, then we can say that opposite sides are parallel. Here we will use these properties. So in proof, here construction is given in the first part. Now in triangle AOB and triangle COD, what we are getting? Already we got OA is equal to OB and OA is equal to OC and OB is equal to OD, because it is given in the question. Diagonals are bisected each other. Then the third part is, you see, AOB, angle AOB is equal to angle COD. Both are the one part of the two triangles. Angle AOB is equal to angle COD. Reason? Vertically opposite angle. So here also we are getting side angle side, side angle side. Therefore by side angle side postulate, by side angle side postulate, triangle AOB is congruent to triangle COD. Okay. So we got triangle AOB is equal to triangle COD. So after showing the triangle congruent, we are getting CPCT. So we can say that this angle is equal to this angle and this angle is equal to this angle. See, I have given single mark here, here double mark. So therefore, what we can write? Angle OAB is equal to angle OCD and angle OBA is equal to angle ODC. Okay. OAB is equal to angle OCD and OBA is equal to ODC. So these are what? CPCT by CPCT. So, but we have to show that sides are parallel. Then it will be this quadrilateral will be a parallelogram. You see, now since from here we will consider, so mark it as equation number 1 and it as equation number 2. Now from 1, since OAB, angle OAB is equal to angle OCD. So OAB is equal to OCD. If we write the full name of the triangle of the angle, then it will become CAB. Therefore, it is equal to CAB is equal to what? OCD. So ACD, angle ACD, and this mark is as question number 3. And from 2, what we are getting? Since OBA is equal to ODC, it implies what? Write the full name. Implies OBA, it will be DBA. DBA is equal to ODC. D, C means B, D, C. B, D, C. Equation number 4. Got it? Now, you see, this mark already given, this angle and this angle. Angle BAC and ACD are pair of alternate angle. Similarly, taking BAC and ACD. BAC and ACD are one pair of alternate angles and they are equal. Taking AC as transversal, so we can say that AB parallel to CD. Similarly, here also, if you consider triangle BD as transversal, then we can say that DBA is equal to BDC. So, since we are writing BA angle CAB and angle ACD are and angle DBA and BDC are two pairs of alternate angle. Alternate angles and they are equal. Taking AC and BD as transversal. So, transversal, taking AC and BD transversal, we are getting that these two pairs of alternate angles are equal. So, we can say that therefore AB parallel to CD and AD parallel to BC. So, if pairs of opposite sides are parallel, then we can say that the quadrilateral is a parallelogram. Therefore, I am writing this line again. Here it is not visible. Therefore, AB parallel to CD and AD parallel to BC. Hence, we can say that ABCD is nothing but a parallelogram. Hence, ABCD is a parallelogram. Earlier we considered this a quadrilateral, and gradually we got this is a parallelogram proved. So, here theorem part is already completed. Theorem 8.6 and theorem 8.7 just we have done earlier. Up to theorem 8.5 we did. Now, one example. Here it is given, but you may not understand it, so I will explain what is written here. Look at your book, page number 165, example 2. Very important question. Show that the diagonals of a rhombus are perpendicular to each other. So, here now we are getting theorem about rhombus. Though it is given in example, so but we will consider this as theorem. show that the diagonals of a rhombus are perpendicular to each other. So let us draw a rhombus. You know, definition of a rhombus is the quadrilateral whose all the sides are equal. Then we can say that it is a rhombus. And if all the angles are right angle, then this rhombus will convert to square. So let ABCD be a rhombus. So here also we can consider the rhombus ABCD. We know that AB is equal to BC is equal to CD is equal to DA. And why given? So I will write a bit elaborately. Example 2, page number 165. Okay. So let ABCD be a rhombus in which AB is equal to CD is equal to AB is equal to BC is equal to CD is equal to AD. Okay. I said just in a rhombus all the sides are equal. So to prove that, what is to prove? To prove that, SC and BD, first we will consider the diagonals. SC and BD are the diagonals intersected each other at O. So diagonal of diagonal SC and BD we have drawn, and they intersected each other at O. To prove that, what is to prove? To prove that rhombus perpendicular to each other. So that the diagonals of a rhombus are perpendicular to each other, we have to prove that AC perpendicular to BD. Okay. So SC perpendicular to BD we have to prove. To prove, construction part is already given in the given part. I have included. Now we are proving. To prove this, we will consider two triangles, this triangle and this triangle. Now you see, you have to remember how the procedure is going. For this, we will consider this, because we will have to show perpendicular. So in triangle AOD and triangle OCD. In triangle AOD and triangle COD. What we are getting? Just to see. As because this is a rhombus, and in a rhombus all the sides equal, so these are the parts of, these sides are the parts of two triangles. So we can say that AD is equal to CD. AD is the part of AOD and CD is the part of COD, and OA is equal to OC. OA is equal to OC. How it is? Just we prove that in a parallelogram, diagonals are bisected each other. So rhombus ABCD is nothing but a parallelogram. So here we can use this logic that a rhombus is a parallelogram, since a rhombus is a parallelogram, and just we proved the theorem that in a parallelogram diagonals of a quadrilateral bisect each other, then it is a parallelogram, or the diagonals of a parallelogram bisect each other. So just we proved that diagonals of a parallelogram bisect each other. So AC is the diagonal of ABCD. ABCD is rhombus as well as parallelogram. So we can say that OA is equal to OC, and this part's region is given, since given, because AB is equal to BC is equal to CD already given. And third part is third part is what? OD. OD is the common side. You see, OD is the common side of both triangle. OD is common side. So, which postulate we are getting? Side, side, side. Three sides we used, therefore by side, 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 SSS postulate. What we are getting? Triangle which AOD is congruent to triangle COD. So, after getting these two triangles are congruent, what we get? Therefore, in as simplicity, what we get? AOD, AOD, angle AOD is equal to angle COD. This is as simplicity. It's because we have to show that SC perpendicular to BD, diagonals of a rhombus perpendicular to each other. So, after getting this, now we will look at the diagram. Since this, you see, AOD and ACOD are what? Can you say? This is a linear pair. Now, since now angle AOD plus angle COD is equal to 180 degree. Here we will write since linear pair. Linear pair, then we can say that it is 90 degree, and mark here, I forget to mark, this is equation number 1. So AOD and COD are equal. So in place of AOD you can write COD, and in place of COD we can write AOD. So we are writing AOD 2 times AOD, plus in place of COD we are writing again AOD is equal to 180 degree. Okay. Therefore implies what we are getting? 2 AOD is equal to 180 degree. So implies AOD is equal to 180 degree by 2. Therefore AOD is equal to 90 degree. So if you see in the diagram, if AOD is equal to 90 degree, then what can we conclude? AOD is equal to 90 degree. Then if it is 90 degree, then this is also 90 degree. Therefore COD is equal to 90 degree. So if AOD is equal to 90 degree, COD is 90 degree, then this part will also become equal to 90 degree each. Therefore we can say that AC perpendicular to BD. So directly we can write here proved. Hence proved. Hence proved means whatever given to prove, I have already proved. So example 2 is also finished. So next we can give a bit hints of equation number, question number 3. So let us do it. No need to give hints. Just opposite to this. Just we proved the diagonals of a rhombus perpendicular to each other. Now we will prove show that if the diagonals of a quadrilateral bisect each other, then it bisect each other at right angle, then it is a rhombus. Earlier it was rhombus. Now we will consider quadrilateral and we will prove it. It is a rhombus, just opposite to this. In earlier class, I have already done up to question number 2. In exercise 8.1, page number 169, look at book. Question number 1 and 2 we have finished. Now we will do question number 3. So here also about rhombus. So let us draw a rhombus. Before that, let us rub this. We will consider this as quadrilateral and we have to prove it is a rhombus. So drawing a quadrilateral. Drawing a rhombus as quadrilateral. ABCD be a quadrilateral. We consider this as a quadrilateral. ABCD is a quadrilateral and AC and BD are the diagonals intersected at O. Simply let ABCD be a quadrilateral AC and BD are the diagonals bisected each other at O. So show that the at right angles given such that what we will write? Angle AOD is equal to angle COD is equal to angle AOB is equal to angle BOC is equal to 90 degree. Because perpendicularly written already and we can write these are equal to 90 degree. These are equal to 90 degree. And here also bisected given. So OA is equal to OC, OB is equal to OD. So mark it equation number 2, here equation number 1. It will be in use later. To prove that, what is to prove? To prove that using these instruments, we will prove that this ABCD is a rhombus. To prove that A, B, C, D is a rhombus. Repeating again, we have to show that a quadrilateral whose diagonals are bisected each other at right angles, we have to show that this quadrilateral is a rhombus. So we have written let ABCD be a quadrilateral, AC and BD are the diagonals bisected each other at O such that OA, AOD is each are 90 degree and OA is equal to OC, OB is equal to OD. To prove that ABCD is a rhombus. Construction part already included in the first part. So we will consider two triangles, two times we will use. First we will use this angle, this triangle and this triangle. What we are getting? Let us see. Proof. In triangle AOB and triangle COD, what we are getting? You see, just simply OA is equal to OC, we can write OA is equal to OC and OB is equal to OD. These are given because diagonals are bisected each other. Next, simply particularly opposite angle we can use angle and angle AOB is equal to angle COD, since BOA particular opposite angle. So which postulate you are getting? Can you guess? Side angle side, side angle side. So we can say that by, therefore by side angle side postulate, triangle AOB is congruent to triangle COD. First part is completed. Now we will use another two angles, this angle and this angle. You see, in triangle AOB and triangle BOC, not this, this. Now in triangle AOB and triangle BOC. Here we are, what we are getting? Again, OA is equal to OC and angle AOB is equal to angle BOC. How? Since each 90 degree earlier we have written, because diagonals bisected at right angle and it is given part. One more part required. We can say that OB is common side and OB is common side. So therefore by side angle, again side angle side, side angle side, SAS postulate triangle AOB is congruent to triangle BOC. So AOB is equal to BOC, and here what can you say? Here remains something. After showing a triangle specificity pattern, therefore here you can say that we have used these two triangles. So AB is equal to CD by CPCT, and mark this as equation number 3. After showing AOB and BOC as congruent, then also we are getting one more simplicity, AB is equal to BC. Therefore, AB is equal to BC. This is also by simplicity. Mark this as equation number 4. Here 3, here 4. Similarly, if we consider these two triangles, now we see I am giving 3 marks. These two triangles, what we will get? We will get this AB is equal to AD. Similarly, now we will not write elaborately, just we will write similarly, short form of similarly, considering triangle AOB and triangle considering triangle AOB and triangle AOD, we will get triangle AOB is congruent to triangle AOD, and hence we will get AB is equal to AD. Mark this as equation number 5. So you see, in equation number 3 what we got? AB is equal to CD. In equation number 4 what we got? AB is equal to BC. Now in equation number 5 we are getting AB is equal to AD. So if we equate equation number 3, 4 and 5, we will get AB is equal to BC is equal to CD is equal to AD. See, that's simple. So you can write comparing equation 1, 3, 4 and 5, we will get AB is equal to BC is equal to CD is equal to AD. So in a quadrilateral, if all the sides are equal, then we can say that it is a rhombus. Therefore, hence we can say that A, B, C, D is a rhombus. Proved. So here the first part almost finished. The chapter quadrilateral is almost finished. Just last part remain about midpoint of triangles. So you see page number 171. Come in the page number 171 here, the midpoint theorem having. Rest, whatever remain in 8.1, you try at home. If you are not able to solve, then you may text me or you may make comment in the comment box. Now last part, the midpoint theorem. You have studied many properties of a triangle as well as a quadrilateral. Now let us study another result which is related to the midpoint of the sides of a triangle. Perform the following activity. You see, we will draw a triangle. Just we have drawn a triangle as drawn in the page 171 and mark it as, name it as A, B, C. Okay, draw a triangle, mark the midpoint E and F. Make E and F are the midpoints of what? AB and AC. If we join EF, what will become? If we join EF, you will say that we will get EF parallel to BC and EF is equal to half of BC. Okay, EF parallel to BC and EF is equal to half of BC. In theorem 8.9, you read out with me. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. Just we will prove that in any triangle, if the line segment joining the midpoints of two sides, the line segment will become parallel to the third side. That is, AB is the first side, AC is the second side, and third side is BC. So EF parallel to BC. We will have to prove this. So to prove, we will nicely draw a triangle. Theorem 8.9. Page number 171. For your reference, ready reference, I am writing the page number also. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. So we have to consider a triangle and name it as ABC. Okay? So let ABC be a triangle. D and E are the midpoints. D and E. Let ABC be a triangle. D and E are the midpoints of AB and AC respectively. What is given? D and E are the midpoints of AB and AC respectively. To prove that, DE parallel to BC. To prove that DE parallel to BC. Construction. Here construction is required to prove this one. So here construction is DE is produced to F such that how much to produce? Such that DE is equal to EF. How much to produce? DE is equal to EF. This much we have to produce. DE is equal to EF. And after producing, we will join CF. CF is joined. This much your construction part. Now what we will get? We will get two triangles forming triangle what? ADE and triangle CEF. Two triangles we are getting. Now next part is proof. Proof. In these two triangles, just we got in triangle ADE and triangle CEF. What we will get? DE is equal to EF. DE is equal to EF. This is by construction. This is by construction. Then AE is equal to CE. AE is equal to CE because since E is the midpoint. DE is equal to EF. AE is equal to CE, and last you see AED, triangle AED is equal to CEF. You see, time is not permissible, so this will be our last sum for today. So what we'll get? This side is equal to this side, as by construction this side is equal to this side since E is the midpoint, and this is angle is equal to this angle since POA, vertically opposite angle. So here we are getting what? Therefore triangle therefore by what? Which postulate? Side angle side postulate. Triangle ADE is congruent to triangle CEF. So just we showed these two triangles which we get earlier. These two are congruent. After congruency, something we will have to get. We are getting what? Simplicity. Therefore, third side, this AD is equal to CE since third side and this angle is equal to this angle. DAE is equal to, clearly I have to write, otherwise you will not understand. DAE is equal to FCE. And one more remain. Can you guess? This is CPCT. One more remain. This angle is equal to this angle, but here it will not be in use, so we will not consider. So this is equation number 1 and this is equation number 2. Now since you see how I will proceed. Now since AD is equal to BD, now since AD is equal to BD, AD is equal to BD, since D is now since no need now AD is equal to BD since D is the midpoint. So AD is equal to BD and AD is equal to CF. AD is equal to CF. Where you got? AD is equal to CF. AD is equal to CF. You see, I have done mistake. AD is equal to CF it will be. So AD is equal to CF from 1. AD is equal to CF from 1. So AD is equal to BD, AD is equal to CF, then comparing above, we get BD is equal to CF. So what we are getting? BD is equal to CF. I am giving a bit largely because you have to understand BD is equal to CF, just to showed. Again, this is equation number 3. We are to show DE parallel to BC. Remember equation number 2 and 3. Again, since angle DAE is equal to angle FCE, I have wrote earlier, FCE. So we can write DA is full name BAC. BAC is equal to FCE full name ACF. So it will be better if you write ECF. Here ECF will become ACF. ECF will become ACF. So from where? From simplicity. So again, since you see BAC and ACF are alternate angle, BAC and ACF are alternate angle. You see, I am giving double mark. Sorry, here not. BAC and ACF are alternate angle. Taking SC as transversal. So SC is transversal, then what we get? Therefore, AB is parallel to CE. Therefore, AB is parallel to CF. So AB's part is BD, therefore we can write BD is parallel to CF. BD is parallel to CF. Now, from BD is parallel to CF, so if BD is parallel to CF, if in a quadrilateral, if one pair of opposite sides are equivalent, parallel earlier, now since BD is equal to CF and BD parallel to CF, BD equal to CF earlier we got, now we are getting BD parallel to CF, therefore we can say that in a quadrilateral, if one pair of opposite sides are equal and parallel, then we can say that this is a parallelogram. Therefore, A, B, C, D is a parallelogram. So, if it is a parallelogram, A, B not, name is BC, DBCF. DBCF is a parallelogram. BD parallel to CF and BD is equal to CF. So DBCF is a parallelogram. If it is a parallelogram, the opposite sides are parallel. Therefore, we can write BC parallel to DF. If BC parallel to DF, then what can we write? BC BC parallel to DF implies DF, you see DF, and DE is nothing but the part of DF, so we can say BC parallel to DE. Hence, what we have to show? The line segment joining the midpoint of two sides of a triangle is parallel to side. DE is the line segment joining the midpoints of AB and AC, and it is parallel to the side. Hence, DE parallel to BC. Proved. Now you see, this is all in chapter 8 of quadrilateral for your class. You see, I am giving some homework in exercise 8.2. Question number 1. ABCD is a quadrilateral in which PQRS are the midpoints of AB, BC, CD and AD. AC is the diagonal. Show that. 3 questions are given. SR parallel to AC and SR is equal to half of AC. PQ is equal to SR and PQRS is a parallelogram. Just using this theorem, the line segment joining the midpoints of two sides is parallel to the third side. You will proceed. You will surely can do. And question number 4. ABCD is a trapezium in which AB parallel to CD, BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. See figure 8.30. You see here given the figure just below the question. Show that F is the midpoint of BC. Using the same theorem, the line segment joining the midpoints of two sides is parallel to the third sides. You can do. If you cannot, then you will definitely text me. I'll try to solve it and I'll try to help you. This is all for your today's class. Thank you.